My term is resonance, and resonance is the tendency of an object to oscillate with greater amplitude at some frequencies than others. Now, a natural frequency, everything in the universe has a natural frequency. It's a frequency that the object has just by itself without any interference. So if this pendulum is like an object, it swings back and forth with some irregular frequency. So when waves hit it at different frequencies, like if it hit it like this, it's not really doing anything. But when resonance occurs, it's just going at its natural frequency, and a resonant wave has the same frequency, and it would keep pushing it at the same time, causing the amplitude to get larger and larger and larger until eventually the system started to shake, and then eventually it would break. So this takes us back to the definition, where resonance is the tendency of systems to oscillate with greater amplitude at some frequencies than others. So the first frequency I showed, the system didn't oscillate very much because the frequency was wrong. But the second one I showed, with the resonant wave and interacting with the natural frequency, it hit it at the perfect time to keep the amplitude growing, and that's resonance. How to find the natural frequency of an object? Here's a glass. If you want to find the natural frequency of this glass, all you'd have to do is hit it. You just hit it. And that's the natural frequency, because no matter how many times you hit it, same frequency, same sound. And a resonant wave is a wave with the same frequency as the natural frequency. Resonant waves increase the amplitude of the vibration in the object until eventually it will start to shake, and like the opera singer with the wine glass, eventually the object will start to shake, and then eventually it'll break. Here I didn't really explain the opera singer and the wine glass example. So basically, if you were to tap a wine glass and find its natural pitch, keep in mind pitch and frequency are the same, so it would be its natural frequency, and an opera singer would be able to sing at the same pitch for long enough. The wine glass, it would start to shake, and then it would break, like you see in the movies or whatever. And this is an example of what resonance is. It's the wave produced by the singer interacting with the wine glass and increasing the amplitude until the wine glass eventually breaks. Just because an object vibrates doesn't necessarily mean that there's a resonant frequency. In your car, if you play music too loud, your car might start to shake if you play music really loud. But it doesn't mean that it's resonant necessarily, it's just that it's loud. Objects can also have many resonant frequencies, not necessarily just the one you hear, but the one you hear is definitely the easiest to find. And that's basically it. I'm going to put a link in the description to another video that explains resonance in case this didn't help you. Thanks for watching, and bye, I guess.